All right, so the data for today, I honestly had no idea what to expect. In a typical year, what kind of relationship would we expect there to be between number of absences and grade? Negative. Now this year it's extremely weird to where for a while there, if you didn't get on Google Classroom every day and then click in the classroom that you got an absent, well, I don't do anything through Google Classroom, so some of you probably were absent in my class because of that. On certain e-learning days, like they've just done it all kinds of different ways. And so honestly, I didn't have a clue what to expect, which makes it more interesting. So we've got our numbers in list 1, list 2. What's the first thing that we're going to do? Make a scatter plot. So basically, I want to see if it's worth my time. Like theoretically, that's where you would start. So we're going to second stat plot. We're going to list 1 versus list 4. Sorry, list 1 versus list 2. Thank you. Probably have to hit zoom 9. And it should look something like this. Do you think that looks like, what kind of relationship do you think that looks like? Slightly negative, maybe not perfectly linear, maybe, I can't really tell yet. So enough to be able to move on. So now I want to do what? Find the residuals. So let's think through this one. So yesterday, that's the thought process we did. We went, okay, let's find the residuals, let's plug it in. We're still going to do that. But at the very, very end, when we ran a test, what did we need in our calculator to run a test? Okay, go to run a test. We just needed list 1, list 2. And then what all did it give us? Everything. So let's start at the end, but we're going to do it with an interval today. So go to stat tests. And so now the only thing we're going to change is what? We're going to go to what instead of what? We're going to go to interval instead of tests. We're going to G. So the only thing you would need to know is what? Confidence level. Let's just do it at 95. So at this point now, if this is an actual like test question, are you still going to have to go back and do all the residuals and stuff? Yes. Do you need all this to be able to do it first? Yes. But if you're going to get all these answers in one place together, why do it twice? So I think it's easier to go ahead and start at the end and then work backwards. So our equation is y hat equals what? 89.2596 minus 0.3258 x. So that's our equation. So somewhere like on the printout that I gave you, I know there's stuff on there which we're getting ready to write on, but basically I'm not going to waste my time. So kind of over here maybe just like write our equation and we'll write our test statistic degrees for, so like we're going to write down everything our calculator gave us so we don't have to keep going back to it. On the back, on the side somewhere. So our equation is y hat equals 89.2596 minus 0.3258x. Our degrees of freedom is 29. What's the other? R squared. And then because it's an interval, not a test, it's giving us our lower and upper, which is the negative 0.599 or negative 0.5994 and negative 0.0522. And then our R squared is 0.1698. Our R is negative 0.4121. Interpret the R squared right now, like out loud. What does it start with? 16.9% of the variation in, let's go context. Simple context. What's your Y? Grades. And the S1 grades, and then what will be after that? Can be explained by, and then least squared regression line of Y on X, which would get in context, of grades on absences for whichever class it is that I chose to do this for. Correct. Right. So what's the only thing I haven't talked about? S. Well, we've talked about S before. What is S? It's standard deviation. This is the only thing that's weird. It is not your standard error of your slope. And I don't like that they do it this way, and that's why we write SE of B here and not just S. There is something else that we deal with that for our class we don't really need to get into context that much about. We make 3 graphs. First one is your scatter plot. What's your second one? Residuals plot. What's your third one? Histogram of residuals. So of our graphs, what are we graphing the most? Residuals. So something about the residuals is really important with the math behind all of the stuff that's going on. So this is actually the standard deviation of your residuals. So that's the average distance, the average amount our guess was wrong from what it actually was. Does that make sense? So in context here, is 10.87 a high or low standard deviation? That means I guessed your grade on average by an entire letter, almost over an entire letter grade. So was this a great linear regression equation to use? What else would confirm that? And what else from that would confirm it? R and R squared. R is telling us it's weak. R squared is saying only 17% of the variation in that line can be accounted for by the least squared regression line. So everything's kind of making sense together. So now could you go backwards and type stuff in your list 3 and then list 4 to be able to do your graphs? I don't think we need to practice that. Like, that's just typing stuff in. Now on the sheet in front of you, sideways, is the way you're going to be given your answers sometimes. We have seen something like this before with chapter 3, where it just gives you this weird printout. That one's a little bit more than we even do. We only get this top section right here. Oops. So because I need you to know this, I am having you actually write this out with me on your paper of plugging in, if we had gotten a printout for the exact problem that we're working on right now, what it would look like. So regression analysis, it says the regression equation is, well, it's set up with blank equals, and then 1, 2, 3, 4 blanks. So here, what goes before the equals? What do you think that is? Our y and our y in context. So for this problem, I'm going to attempt this. And now it's usually pretty shorthand. What is our shorthanded y variable for what we're dealing with right now? So that's our S1. And so I'm writing our example up here, and I'm going to write what actually goes there below it. In our equation, what comes first? Y-intercept, which is A. For this problem, that was 2596. Now this I made a tiny little blank here because it's either going to be what or what? Positive or negative. In this particular problem, it was negative because our slope's negative. What was our slope? Negative what?
0.3258.
And then it just put words here. In general, that's our what? So context is going to be absences. In general, that's
Would the first y be y hat?
if you are writing an equation and you are doing it, your equation should say y hat. This program that AP Stat uses, which is the Minitab output, writes it like the way the problem is. So it's not saying why. I don't know why they don't do hat in there. But it's just, so like I'm getting you to see what this answer would be like. We're just working backwards. When you write it, you would write y hat. All right, so then the next thing, I did it kind of like a table just so you can see how it's set up. We're writing this. So it's always going to have the word predictor. So that's this category. That first one is always going to be the word constant. Well, what's the constant thing in our equation of these, which is the constant? This one, because that one changes. What's this one say? So the number that goes, the first number that's your constant is your y-intercept. What's after that? And then, all right, so this one, I don't have anything written there. This is always going to be your x variable, which in this case would be absences. In your equation, what always goes inside of your x? Your slope. So whatever's inside of your x here is your slope. We found a test statistic for this problem. Did we find a test statistic for the y-intercept or for the slope? For the slope. So this is our x, this is our t, this is the t value that we found, our test statistic value that we found, which is what? We did write the test. Switch it and do test really quick because I need you to. Like go back to stat, calc, F, whatever it is.
What do you want us to do?
Less than or greater than?
Oh, yeah, less than. So this is our test statistic from our equation. Then what's beside of it? P-value, what's the, now, this is something really important. What do you think is going to go here? That's our standard error of our slope. If it were given, that's where it would be. This is our test statistic. What's that one? What's this? What's this? For our class, we do not use this. Now, if for some reason they give you some crazy question on the exam and they ask, well, what would the test statistic for the intercept be? That's what it would be, but we don't deal with that. The only thing that's weird about this is when you go through Minitab, you don't tell it if you want less than, greater than, or not equal to. So it always does so that is a two-tailed test. So what was our p-value when we typed it in the calculator? So 0, 1 something. So what would be here in the Minitab output? We did a one-tail, so what would the answer be if it were two-tail? 0.02. So this is twice. So if you want HA as less than or greater than, divide this by 2. And that's pretty much the only thing that could possibly get tricky with this. So you're never going to have to make a Minitab output for any problem. But you now just made it so you know every piece to it. What's going to happen is you're going to get a question on the AP exam, and they're going to say, here's all of this. Now run a test. Would that be an easy problem? Yes, you have all of the information to do it. Like, there are even times where it'll say, here are all 3 graphs. Here is the Minitab output. Now run the test. That would be a very easy problem. Does that make sense? So I'm giving you the information like this sometimes. We just did the hard thing and filled in the pieces. The only things I didn't talk about were S and R squared. What do we say S is? And we just got that one in our calculator. And I'm really hoping I don't have to explain R squared to you. Sometimes there's an R squared adjusted. You might want to write beside of it. So if there's an R squared adjusted, don't use it. And y'all can write in whatever these numbers were from our example, because we already wrote them down. But you got like 2 more minutes. I don't remember what the numbers were. 10 something and 16.78 maybe. 98. And it was
10.872.
Last number was what?
5.
Is this in like the
Oh, I didn't write it in yours. Yes, that's the box under where